start off with the basics. First we have position, which is the initial function. Then we have velocity, which is the first derivative. And then you have acceleration, which is the second derivative. So once you start off with your function, you have to take the first derivative to get your velocity. Then you take the second derivative to get the acceleration. And it's shown below. F of x is position, f prime of x is velocity, and f double prime of x is the acceleration.
So a commonly asked question is always, what is the displacement versus distance? And a distance is the total amount that one has traveled, when displacement is the change in position of that movement. So, for example, if one was on a track, a normal track, the distance would be the amount that they have traveled. But the displacement would actually be 0, because you finish where you started.
So position is the original function. To find the position when t equals 3, you take 3 and plug it into t, and then that gives you your position. So the position when time equals 3 would be 43.
So to find our displacement, we're going to take the integral of v of t from 6 to 1 in order to find our change in position. Once you plug this into your calculator, the answer will be -95, which is our change in position, or our displacement.
Okay, so to find the total distance, we're going to follow the same process as we did with displacement, but this time we're going to take the absolute value of the integral of velocity in order to cancel out all negatives and accumulate a total distance.
So to find our final position, we have to take the integral of v of t from 5 to 0 in order to get our displacement. But we have to take into account where we started, which is when s of 0 equals 2, or when our original function, when t equals 0, is 2. And so we take our integral of v of t, and then you have to add 2, not with the integral. Plug that into your calculator, you'll get 1.04. And that is our final position.
Okay, so there's a difference between average rate of change and instant rate of change. Average rate of change will be explained later, but instant rate of change is at a specific hour. So all you have to do is to take the derivative of the function and plug in that hour for t. So you take the derivative of that, and once you plug that into your calculator, you'll end up with 64.3 bacteria per hour. That's because we're going from the original population to a changing value, or the rate of change, at hour 2.
Okay, so to find the average rate of change, we will be following the formula p of 2 minus p of 0 divided by 2 minus 0. So basically we're going to take 2, plug it in the equation, and then take 0, plug it in the equation, and divide by 2. We do this because we'll be finding the population at time 2, and then the population at 0, and then when we divide by the time, by the total time, that will give us the average rate of change. So when we plug 2 and then 0 and then divide by 2, we end up with negative 2.26 bacteria per hour.
So to find the average value, we have to do 1 over b minus a, which is our time. So in this case, b is 2 and a is 0. So we have 1 over 2 minus 0. And then we multiply that by the integral of our population from 2 to 0. Once you plug that into your calculator, the answer is 111.54 bacteria. So we're going to start off with the basics. First, we have position, which is the initial function. Then we have
What are you doing?
What?
Why'd you write an equals?
So all I had to do was plug in 2 for t and to take the derivative of that. Wait, I didn't take the derivative of it. Did I? Average rate of change will be explained.
Why did you laugh?
I couldn't keep a straight face.
I'm literally just zooming in your face.
So to find the average value, we have to do. You're looking at him getting.
Alright, so there's a difference. Don't look at me in the eye. I can't.
What?
Okay.
Okay. So this is it for our video. Hope you guys enjoyed.
Please like and hit the subscribe button.
We're
See
so
you next
cool.
time.
AP Calc review.
Bye.
Bye.